Welcome to the first of two parts on the conic section, the hyperbola. The goal of this video is to graph a hyperbola in standard form. A hyperbola is the set of all points xy for which the absolute value of the differences between the distances from two distinct fixed points called foci is constant. Now I think the best way to get a feel for this definition is to take a look at an applet. The hyperbola is graphed here in red. The two foci are here and here. So what you'll see is two segments from this point in blue to both of the foci. And what that definition is saying is if we find the difference of these two lengths and then take the absolute value of that, it'll be the same for any point on the hyperbola. So for example, right now, I'm not sure if you can see it, but they're taking this short distance here and subtracting this longer distance, and that difference is -8. So if we take the absolute value of that, it would be +8. And that'll be true for any point on the hyperbola. If I move this point, as I animate this point, the common difference remains -8, and the absolute value of that would be +8. If I move this point to the other piece of the hyperbola, the common difference is now +8, and again, the absolute value of +8 will still be 8. Let's first take a look at some of the key features of the graph of a hyperbola. First thing you'll probably notice is that hyperbolas can open left and right or up and down. And that's based upon whether the transverse axis is horizontal, as we see here, this is the transverse axis, or whether the transverse axis is vertical, as we see here. Hyperbolas have a center, as we see here in blue. Hyperbolas also have 2 points that are on the hyperbola and on the transverse axis called vertices, as we see here in red and here in red. Also on the transverse axis are the foci, and you can think of those as being inside the hyperbola, again, whether the transverse axis is horizontal or whether it's vertical. And then lastly, you'll see these green lines that are called asymptotes. These are lines that the hyperbola approaches but will not cross. And these are very helpful when we go to make the graph. So let's take a look at how we're going to be able to determine all of these key components when the graph is in standard form. Now this is a busy diagram, but it contains everything you need to know in order to graph a hyperbola in standard form. First, we'll notice this looks very similar to an ellipse, but now we have a difference rather than a sum. And when the x part of the equation is the positive part, notice that the hyperbola will open left and right and will have a horizontal transverse axis. If the y part of the equation is positive, then the transverse axis is vertical and the hyperbola will open up and open down. Notice that a squared will always be under the positive part of the equation and b squared will be under the difference or the negative part of the equation. Once we identify a squared and b squared, we can find c squared by using the equation c squared equals a squared plus b squared, because now c will be the longest length. Once we find a, b, and c, we start by locating the center, which has the coordinates hk, and if we have a horizontal transverse axis, we'll add and subtract a to the x-coordinate to find the coordinates of the vertices, and we'll add and subtract c to the x-coordinate, and we'll add and subtract c to the x-coordinate of the center to determine the coordinates of the foci. Now what I want you to notice is this rectangle that's between the two pieces of the hyperbola. It has the dimensions 2a by 2b, and the reason this rectangle is so helpful is the lines passing through the diagonals of this rectangle will be the asymptotes of the hyperbola and therefore are very helpful when making the graph. Now everything is very similar when we have a vertical transverse axis, except now we'll be adding and subtracting a and c to the y-coordinate of the center to determine the vertices and the foci. Let's go and look at an example and see if we can put all of this together. The first thing we should notice on this equation is that the x part is the positive part, which means we'll have a horizontal transverse axis, so our graph should look something like this as we see down below. Next, the center of the hyperbola will have the coordinates hk, so the x-coordinate will be +2 and the y-coordinate will be -3. A squared will be under the positive part of the equation, so a squared equals 4, so we know a equals 2, and b squared equals 9, so b equals 3. Let's go ahead and find the value of c. Remember, c squared equals a squared plus b squared, so c squared will equal 4 plus 9, that's 13. So we'll have c equals square root of 13. And I already found the decimal approximation for this because that's helpful when we're graphing. So c is approximately equal to 3.61. Okay, so let's go ahead and start by plotting the center at 2, -3. Again, keeping in mind the hyperbola will open to the left and open to the right. The two vertices of the hyperbola will be a units to the right and a units to the left of the center. So since a is equal to 2, one vertex will be here at 4, -3, and the other one will be at 0, -3. Remember, these are 2 points on the hyperbola because we know it opens something like this and something like this. The next thing we want to do is create this rectangle here with dimensions 2a by 2b so we can sketch those asymptotes. The length from this red point to this red point is 2a. This would be the width of the rectangle. The question is, what would the height be? Well, the height would be 2b, and since b is equal to 3, 2b would be 6. The rectangle would have a height of 6 units. So we'll sketch a rectangle 6 units high by 4 units wide, like so. And again, the diagonals of this rectangle will be the asymptotes of the hyperbola. So let's go ahead and sketch those. Believe it or not, this is enough information to make a nice sketch of this hyperbola because we know each piece is going to approach these asymptotes. So it's going to look something like this and also something like this. Now we should go ahead and find the coordinates of the foci. Remember, that's going to be c units to the right and left of the center, where c is approximately 3.61. Foci 1 will be 2 plus 3.61, comma -3, and the second foci will be 2 minus 3.61, comma -3. Well, this will be 5.61 -3, way over here on the end. Call this foci 1. And this is going to end up being -1.61, comma -3, somewhere in here for foci 2. Now we're not going to take the time to find the equations of these vertical asymptotes. Sometimes you're asked to do that, but you could quickly find the slope of these lines and then use point slope form to find the equations. Let's go ahead and take a look at one more example. Notice on this hyperbola, the y part is the positive part, which means our transverse axis is now vertical, and therefore the hyperbola will open up and open down as we see pictured here. Our center will have the coordinates positive 2, -4. A squared is equal to 4, therefore a is equal to 2. B squared is equal to 16, b equals 4. Remember, a squared is always the denominator of the positive part. And let's go ahead and find c while we're here. C squared is equal to a squared plus b squared, which would be 4 plus 16, that's 20. So c equals the square root of 20, which is 2 square root of 5. And this is approximately 4.47. Let's go ahead and see if we can sketch this. We'll first plot the center, 2, -4. We know this parabola is going to open up and down, so now we'll have to add a to the y coordinate to find the two vertices of the hyperbola. Since a is equal to positive 2, we'll go up 2 units and down 2 units. So this would be 2, -2. This would be 2, -6. Those are 2 points on the hyperbola. So now we'll go ahead and sketch the rectangle so we can form the asymptotes. We already know the height of the rectangle now. Now we need to determine how wide it would be. It would be 2b units wide. Since b is 4, it's going to be 8 units wide. So we're going to sketch a rectangle that from here would be 4 units to the right out to 6, and 4 units to the left out to -2. And from here we can finish our rectangle. It will go up to this height and then over and then back down. Now the asymptotes will be formed by the diagonals of the rectangle here and here. So from this vertex, the hyperbola will approach the asymptotes to the left and to the right, and the same below. But we should go ahead and find the coordinates of the foci. So now we will add and subtract c from the y coordinate of the center. The first focus, 2, -4 plus 4.47. And the second focus will have the coordinates 2, -4 minus 4.47. So this focus will be 2, positive 0.47, somewhere in here. and this will be 2 negative 8.47, somewhere down here off the screen slightly. Okay, that'll do it for this video.